I hope you're here for this discussion that we'll have around developer productivity tooling, specifically the tools that we on our team in Visual Studio ALM, or Application Lifecycle Tools, focus on helping developers improve quality and have a more pleasurable life living inside your code editor. That's my big thing. I want to make you happy. So hopefully some of the stuff that we show you today will make you feel happy. Who's heard of the happiness metric? Anybody heard of that? There was an article on the front page of the Harvard Business Review. I want to say it was a while back, last year, in which it was asserted that if you measure the overall happiness of your clients and your employees, it is the best indicator of ROI and profitability that your company can measure. Don't know if it's true, but it was an interesting read. I hope you're happy after this. This is who I am. There's your Twitter handle so that you can behave abusively accordingly. And this is the state of modern software development as we, in Application Lifecycle Tools, learn about it as we go out and talk with our customers. And sometimes they come and talk to us, but we've been spending more and more time away from the Microsoft campus to better understand what folks like you need, want, and appreciate, and what types of problems you are trying to solve. These are some of the tenets that we have discovered along the way. I've only been at Microsoft about 9 months, so I'm right on the verge of being irrelevant, but not quite yet, which is handy for me because I have experience with some of these things. Large code bases in particular are particularly costly because mediocrity scales, right? It's very easy to scale and get it wrong. That's hugely easy, and we've all probably been a part of that. But large code bases are in fact the norm, and as we look at larger and larger, both online and cloud systems, those things begin to look to me more and more like helicopter systems with very large code bases. I like to think about helicopters and airplanes as being two different things. An airplane is a single machine with a single intent and a single purpose, flying as a unit. That would be more like your app store sort of thing. A helicopter is 50,000 parts flying in formation, and that would be your cloud system. If the cotter pin on one of those pieces were to shear away, disaster would ensue. And it's in there that we have the biggest risk as software developers, because these larger and larger code bases, even right down to the method and property level, become very difficult for us to understand and maintain. I hope to give you some tools that can help with that. You already have unit testing frameworks, by the way, which are hugely useful. See what else we can do. Continuous delivery is no longer just something that those guys back in Redmond are talking about, or those hippies on Twitter. We're actually doing this. We're delivering software more and more frequently. I just had an article come out 2 weeks ago or so, entitled "So Long and Thanks for All the Manifestos." It's a Visual Studio magazine. I think it's online. And what I assert there is that it's been a great, fantastic 12 years. You 17 wizened gentlemen of the Agile Manifesto, thanks so much. And we're past that now. Now, what we think about more than anything, I believe, are these three tenets. Ship often. Keep quality high. Use feedback to improve. It's that simple. Those three things. Simple doesn't mean easy, though. And these things are terrifically difficult, in fact. One of the things that makes it so hard is this. In a world where things are moving so quickly and we're having to change our orientation so quickly as we look at one pile of code and then another problem, and now the production site's down, and now we've got a problem in some back-end database that we have to go look at. We turn out to be, human beings that is, decent multiplexers. We are not, however, multi-threaded. Turns out we have two threads, one that keeps our heart beating and our breath going, and the other one, which is what you're thinking about right now. Two threads. And switching is really not something we do that well, because what we do is we multiplex. And we also know that our likelihood of error as we multiplex more and more things goes higher and higher. So, for example, if I am driving my car with my 4 kids in the back, drinking a cup of coffee, listening to the radio, and then my wife calls on the cell phone, I'm going to kill you. Going to crash into something at that point, odds are. In fact, odds really are that. Well, this constant context switching that we ask of ourselves and of our developers is tremendously costly, and the time to reorient, I'm sure you've heard all these stats, we've been talking about this for years, it's just tough. One big reason for this, we all know it, but why? Well, it turns out that the human brain has 8 registers. I didn't know this till recently. I have the pleasure of working with a gentleman who has a specialty in computer-human system interaction, that sort of thing, and user experience design of software. And he's taught me some really neat stuff, like these things. That we have about, actually 7 registers that we can switch between consciously. Now, what's really interesting when you think about that in the context of exploring code is that means I get to hit F12 6 times before I have no idea what's going on anymore. So I follow a method, I follow a method, I follow a method. Oh my gosh, what is this class doing? I have no idea. Back, close it, start over. That was 3 minutes I'll never get back. F12. Right, you done this? We all do this, right? Okay. Turns out there's this thing, situational awareness, which sounds, in this man's definition, this gentleman, M.R. Inslee, to be a very complex thing. I don't think it is. It's not that complex. Situational awareness is simply knowing what's going on around you. In my experience, I have 4 teenagers right now. Well, one's 12. I have 12, 13, 15, 16 in my house. There's a lot of hormones in my house. And there is a lot of stress. And when there is more stress, decisions get worse and worse. It's remarkable to watch how it just dives like that. One's decision-making ability when one is under stress. This drawing on the right is part of a diagram that explains something called an OODA loop. An OODA loop is something that was originally proposed, I believe in the early 1970s, by a gentleman who was a fighter pilot named John Boyd. And what he was talking about specifically was the decision points or the steps that fighter pilots go through as they have to make a decision about whether to turn left, turn right, go down, go up, pull the trigger, whatever the case may be. And those steps are to observe your surroundings, orient yourself to that reality, accept it, because we're here, decide what you're going to do about it before consciously making the step to actually do so, and then finally and lastly to act. Now, in a fighter pilot, that takes place in tenths of a second. In a software development team, the results are usually a little less severe, but the situational awareness requirement is extremely high, particularly because it's a team sport. Software development is a team sport. like it or not. What's really fun about that is that I was reading another book last night, actually, on my phone called The Psychology of Computer Programming. And he asserted in that book that meaningful software, that is software that is genuinely complex, that is genuinely meaningful in its accomplishment, will most likely be written by a team of people, and that team of people would have certain behaviors were that software endeavor to be successful. This is really cool. This is a good read. And it was written in 1969, and all of the code samples are in Fortran, which I didn't know Fortran was that old. Maybe it's been rewritten. I don't know, the book. But anyway, this idea of situational awareness is key because we need to orient ourselves not only to each other but also to the code, which turns out to be a terrifically hard problem in many cases. Let's get there. All right. One moment here, I'll get cleaned up. I had a fun little run to get over here. I'm just coming off of another talk. There we go. And things may not be perfectly smooth here. Okay, we're looking at an application. It's called Trembler Map. I'll run it here. Just do a quick control F5. Oh, it's already running. Excellent. Look how prepared I was. What we're seeing is real-time data coming back from the USGS, that's the Geological Survey feed of earthquakes within the last little while, last few days. Anybody know of an earthquake that's happened somewhere in the world in the last week or so? I can't hear if anybody is suggesting one. Let's take a look over here. How very typical of us to have defaulted that view to North America. Okay. Here we go. I think the closest one to Spain recently was here in Italy. It's a 5.1 on June 21st. That's a big earthquake. So this is the code that we're going to be looking at. It has some complexities to it. And as I come to this code and begin trying to better understand it, I need some tools to, I guess one thing I could do is I could just start stepping through it, right? That's what we've done for years. F5, F10, 10, 10. You get 30 minutes into that, stop, start over. Well, there are other ways to experience code, and what we hope to do is provide some of those. So I'm going to start with something. I'm going to look up some piece of code in here. The start timer. There it is. This little guy. This method is a lovely little method. Has lots of good things going on inside of it. It's some of the cleanest code you've ever seen in your life. Well, to better understand this code, one thing I could do is show it on a code map. Who in here has used code maps? Cool, not that many. Code maps have been around now for about a year, and we've invested progressively in this technology over the course of the year. This comes from initial investments years ago in architectural tools like sequence diagrams and use case diagrams and all that stuff. We've repurposed that technology to expose information about our code in a little bit different ways. Well, that's not very interesting, you might say. There, Dave, can you read that? Back in the back? It's a big room. Yeah, that's not terribly interesting. But what we could do from here, perhaps, is we could right-click this node, which represents a method, and we could do all kinds of things with it on this code map. We can show other relationships. If we had more interesting graph here, we could lay it out in different ways. I'm going to select this node and do something that apparently Not that many people do, but I really find that it helps me orient myself to this code more quickly, and that is to show this start timer method in the context of the entire hierarchical tree that contains it. It takes a minute for this to render up. This is on a virtual machine whose milk has been strained significantly in the last 2 hours. Probably needs to be lovely. Did I get a build failure? Probably needs to be balanced at this point, but we'll make it through. Yes. The typical, you were running the app so it couldn't build and overwrite the DLLs. Because apparently I'm an intern. That's cool. This helps me visualize data that's already present inside Visual Studio in very different ways. And you're going to see that theme through a lot of the tools that we and ALT have been making over the last few releases, particularly in the group that I'm a part of, which is the developer experience group. We care about the experience you have writing code. And other folks care about things like the work item management system that you use, the version control system that you use. I care about that too. The build system. We care about the experience of a developer within Visual Studio at the enterprise. Okay, so this is a continuation of those types of investments. Now, what could I do with this from here that might be interesting? What if I showed methods that I called? So what is start timer doing in there? Turns out it's doing quite a bit. So it's making some calls out to some other things in that class. So you can see the main page view model is a class. It contains a start timer method. Start timer method is calling the setter on the refresh message property. And it's calling refresh data. So that's pretty nifty. It's a good way to start, seeing something like that. Now, from here, we can continue to drill in. Actually, this is the one I want. And we could say, for example, show everything that you call, or that calls you. Now we could, let's do this. Let's look for who calls start timer. There we got an explosion. I'm going to zoom in here. This is a very difficult thing to do on a projector. Those big monitors you convinced your boss that you really needed, you really do now, and that's cool. So I'm going to come up here and try a couple of different layouts to see if I can get this to look a bit more readable before. There we go. All right. So here's our initial exe package. I'm clicking incorrectly, which I didn't know was possible, but apparently is. There it goes. Okay, so you can see when we explode it that there are a lot of things pointing at this start timer method. It turns out, though, that if you read the names of these methods, these things are all tests. And let's see. What if we could just group them all? And we could drop these things into these groups, and then we could say, you know what, those are tests. I can even rename that group. This has got to be terribly difficult to read from the back of the room. We'll be done with this in just a moment. So we could do something like this where we create our own structure and then decide that we'll just collapse all those. Alternatively, we can back right out of all of that with undo, get to here, select all, and show container. What this will do is it'll show the container of everything that I've currently selected, and all of these test methods should show up, look at that, in a container called main page view model tests. That sounds reasonable. I can collapse that, and now I'm back to looking at just my system under test code, which is not nearly as complicated as we first thought it was. This is the type of tool that we want to experiment with, to try and put in front of software developers a new way of experiencing software, of experiencing code. It's just a different visualization, and you can put different visualizations on top of this even. I would encourage you to play with this. We can do several things with this that you wouldn't necessarily think of from if you're familiar with the old architecture diagrams. We can do things like annotate this drawing. We can put a comment on it. I could note that I should follow up on this. Things like that. I can save it. And I could do that before, but now I can share it. I can copy this to my paste buffer, throw it in an email. That's the intent behind agile modeling tools, which this is one of. This is a discovery tool that's purpose-built for discovery versus prescription. We're not going to tell you how to code with this tool. We're going to help you understand what the code already does. It's still an architecture tool. We're going to use it in a very different way. Wouldn't it be neat if we could do even more? That's been around since Update 1 of Visual Studio 2012. And now we've gone a little bit further with it. But with CodeMap, you can create these representations of your code, annotate them, save them off, turn them into other document types. They're meant to be disposable. That's key. The original attempts that Microsoft made with the modeling tools didn't really feel that way, although we encouraged everyone to use them as disposable artifacts. But this code map goes the next step, I think, that really feels better and feels right. And what we can do with that, even beyond building a simple static code map, is we can look at this software at runtime. I'm going to hit F5 after having put this break in. Okay, so I hit our breakpoint. Lovely. And note up here under the debug menu, this button, I don't know if you can see this, and I'm not going to be able to zoom in, unfortunately, as it is a virtual machine, but there's I can't get in there right now. So there's a code map button here. This would put us on to that stagnant code map that we just looked at, wherever our cursor is, in this case, refresh data. However, over here under the debug menu, we now have show call stack on code map, which is a little bit different. And it turns out, here I'm going to close Solution Explorer there for a moment, that as we walk through our code, actually I needed to dive into that. I should have F11'd into some of that. Let's do that one more time. Note that the map stayed in place. That was actually kind of cool. The map stayed there. And I'm going to F11 instead of stepping over and go into this thing. See the map changing? I'm going to change its layout. We'll go top down. This is how most people are used to seeing these maps. Well, F10, F11 doing a wait. Oh, there's some async code. Looks like we're handling that. Very nice. We just stepped out into some external code that's calling on that async return. there's stuff going on there, then we're finally able to see it. Let's see. Probably need to get out of this. So go up one. Right on. Meanwhile, I still have this code map with debugger integration. Note my breakpoint is visible, and this is my current location in my call stack. Note the coloring. These other things are not currently part of the call stack, which must mean that I'm being invoked, this refresh data, from this external code. I'm going to stop debugging, and I get to keep the code map that I created. And what's really neat is that I'm very suspicious of this. So what I can do now is flag it for follow-up, and because I actually heard in a presentation at work that if you wear a purple shirt, people think you're smarter, we'll make it purple. I had to go to that. Okay. We could, again, have all the other features that we had on CodeMap right here on CodeMap plus debugger stuff. This is the start of a new way of seeing not just your code, but your software. Because this marriage of data plus the code is absolutely key to being able to truly understand what our software is doing. I like to think about data as being the water that flows through the pipes of our code. It sort of hydrates our system. We can't truly understand how our system is going to react unless we run it and observe it and play with it when it's fully hydrated. So there we go. Hopefully, this will be a way to not spend so much time going up and down the locals window and call stack. I'm going to let go of this code map because it too is disposable and meant to be. So we'll open up Solution Explorer. Did you know that Control semicolon gets me Solution Explorer? Control semicolon brings it right up. And Control, let's see. Where'd it go? I must not have Team Explorer. Oh, there it is. Well, Team Explorer is typically bound to Control, comma. All right. We're back in here. And one of the things that my team in particular stewards forward is this feature called My Work. The intent of this feature is to provide a single unifying place for developers to go to see what data or to see what tasks lie before them. Now, that's simple enough to say, but there's a little more to it than that, because quite frankly, you can pretty much get that with the query off of your Team Foundation server and your work items. There are a few more things going on here. One is that I currently have been assigned, oh, and by the way, I'm logged into this VM as Brian Harry. Isn't that awesome? Here's what's really cool. This is how I got to start my day. Who was at the keynote? Wow. Some of you guys do get up early. That's great. So you're at the keynote this morning, and there's this one brief moment. It lasted like 3 seconds, where Brian Keller was showing the team room where the different conversations can go on amongst team members, and Brian Harry sent him a code review. Can you believe that? The gall of that man. Okay, I got to type that. Isn't that cool? So that's how I got to start my morning, pretending to be Brian Harry in the keynote. Okay, so here we have these three things that have been assigned to us, and this looks a little different than it may have looked before. One of the reasons, or the reason for that, is that I now see more work item types here than just bug and task. under my work in previous versions of Visual Studio, you are able to associate bugs and or tasks to the work that you are about to do. And that's the key here. Normally, the workflow for a developer is go into work item management, find out what problem I need to solve today, maybe drag some virtual cards around on a web page, and then I go in and I just start slinging code, and I feel like I'm pretty good at some point, so I go to do a check-in. And when I do that check-in in my pending changes dialog, I'm able to then associate a work item with the check-in that I'm about to perform. That doesn't work because we just forget about it. We just forget to do it. So what do? We do what good software engineers do. We write something called a check-in policy. We write a program to tell the human they're not doing the right thing. So now we've got a check-in policy that will remind you to associate a work item, and that's irritating. And so how can we be a little less annoying? What if, before we even start working, we decide deliberately what we want to work on, and we put that thing in motion? That's exactly what I've done here. Let's see. I want to go up to our web access portal. And hopefully you were lucky enough to see some of the discussions from Greg Bohr and Martin Woodward earlier today. We were talking about agile project management here. We look at this backlog on a board. We can drag these things around to these different states. And alternatively, we're able to do that with my work. So my work means that as we do check-ins in the future related to this particular task, that when we do so, these work items will transition between the appropriate states, saving a few clicks. So that's a cool thing. Let's go back into my work because that's not really the big value prop there. The big one is the fact that, look at this method. Isn't that great? Oh, it's a good thing I'm going to bed early tonight. Okay, so maybe I'm starting work here on my enable manual refresh, and for some reason, extracting this into its own method is a part of that work. Let's see. Let's go extract method here. Sure, I trust you. I'm just making a code change is the real truth here. So we're going to create a new method, wrapping up some functionality in that method. I'm going to build. Let's hopefully at least get a compile. Now, one thing to note is this Test Explorer over here, which has a magic secret button. It's this button. And what that reads is run tests after build. So if I select this, I now no longer have to look at the Test Explorer because instead I can simply go to build, solution, and my tests are running. They just ran. So it looks like we do have a failure. Looks like it's that one. We will deal with it later. So the next thing that I can do is respond to the fact that I'm probably going to get interrupted today because my boss knows we're all multiplexers but doesn't care. And the website's down. And I have to go work on a hot fix. In order to do this, what I might choose to do is to suspend my work. And I can suspend my work to a shelf set inside Team Foundation's server and include in that shelf of work all of my personal Visual Studio settings to include the breakpoints that I've set, the window layout. Notice that I happen to prefer, because I'm old, by the way, this is because I'm old. I prefer Team Explorer and Solution Explorer on the left because that's how it was in 2000, apparently. And I still do that today. It's the first change I make. That setting will get serialized to this shell set that we're about to create. I'll call it must go fix the server. So I'm suspending my work. Now it's not going to make what I'm working on go away. My project's still here. And in fact, that's okay, because what my boss really wants me to do, because we've done this 1,000 times, is he wants me to take the code that's on my machine right now and come in and make a fix to it, so which I will do, and we'll pretend that this is it. You know what that is? Fix on. That is fix on my machine. I'm going to fix on my machine. I'm going to build. And I'll just go ahead and zip up those binaries and send them to him, and he'll mail them to the customer, probably in a zip file. It'll be great. Don't worry about it. But now I can go back to work. By the way, no, not really. This is the idea that we need to suspend our work in some cases to go deal with a different emergency or some such thing. All right. So we go back to our Team Explorer. Notice that my fix is still in this code on my action command here. And I've got this suspended work. So I could merge that work with what's in progress. That wouldn't make for a very interesting example because we've only created this comment. However, what I could do is I can investigate what was going on with this code at the time that I suspended it. I can see that I was associated with the enable manual refresh work item. This happens to be a product backlog item. And I can look inside the pending changes. These were the files that had been changed at that time. So, let's take it. Let's go ahead and just revert. And so, my fix will hopefully go away. That was on my action command. Cool. So I just pulled my work in progress, complete with breakpoints, I believe. We should find those under start timer, right? Because that's where we set breakpoints. There. All right. So we looked at code map debugger integration. And code map debugger integration allows us to see that call stack right off the debugger. And it's really cool because I forgot to mention this when we were looking at it. All we're doing is showing that call stack in a very different way. Basically parsing it into some XML, which reads into that DGML file, gets rendered. Cool, pretty, awesome. Well, it turns out that since all we're doing is parsing a call stack, we can do that for any language that you might be developing inside Visual Studio. So these maps work, these debugger maps. Shouldn't say it that way. Code map with debugger works for C++, for JavaScript, and for whatever managed languages you want to. You might happen to work in some of those as well. Okay. Now there's another thing that goes on out there in our world. It's a fairly general problem. And we talked about it already, this need for a harmony, an understanding of what's going on amongst the team. We also talked a little bit about fighter pilots because they contributed to the thinking in this space, that OODA loop from John Boyd, but also the solutions that they brought to the table. So one thing that we know about developers, is that we need the situational awareness to stay high. Those 7 registers in our conscious thought need to be full of the correct information. But that information is not at our fingertips. It is, however, it turns out, in Visual Studio. It's all in there, if you can figure out how in the world to get at it. that data, which will help you understand that code so that you can make better decisions about it. So what do we do as we're writing code to learn about the thing we're writing? We have tons of windows open. We look back and forth between the windows. We all have multiple monitors now. And that code map's great, but I'm definitely going to put it on another monitor. So we're taking up a lot of real estate. That's cool, but it necessarily means that we're switching to get that data. So we're making a mental switch to jump to those other tools. We also know through study, this is not just, I was surprised, I got to tell you, having not been at Microsoft that long, stunned in fact, to find out how much investment goes into understanding of human behavior and interaction with the software that we're creating. And so we have measured and understand that developers want to stay in the editor. That's why you can still go get Vim, right? Because Visual Studio does all this stuff and the kitchen sink. And I just want a good editor. So, turns out we agree and would like to leave you there if at all possible. Because we know that when you leave the editor, that's a disruption in your flow. It's a loss. It's a context switch. You're going to lose something. And every time you do that, you lose one of your mental registers. I'm going to zoom in on our start timer method. When I do that, you can also see this little line right here that we call the code lens indicator line. This is a set of, oddly enough, indicators that bizarrely indicate some data about the thing you're doing, either about the context of your human work, that might be what's changed over time, or the context of current state, what's referencing me. So this is a different way of looking at information that's already inside either Visual Studio or in some cases Team Foundation Server. Let's start with references and take a look at how references works. Today, there are some interesting things about references and how they are realized. I got to tell you, I had no idea the level of detail and scrutiny that goes into what is a reference. It's really interesting. So when you hit Shift F12, let's find all references today, which we could do on this method. Let's do that. Shift F12. Look at that. We have 8 matches. But that code indicator line, that code lens indicator says that we have only 7 references. Now, why would that be? If you've had to go through a rigorous study of references, which most of us have to do at some point because you're trying to figure something out, what you learn is that one of these nodes is self. Turns out I reference me in casual conversation. So that's a thing that we decided was interesting but easily omittable, so we did. And we're working on different ways to visualize these references in more meaningful groupings, more meaningful pivots. For example, would you like to see your references organized by file, by type, by something else? I'll bet you can come up with 1 million of them. How about by namespace? There are different ways to view all this data, and that's really what this is all about. Further, there's the question of what is a reference. That still remains, by the way. We are answering that question in CodeLens by talking to something called Roslyn. Roslyn is a software project that has not RTM'd, that is not shipped. It is very much a pilot body of work inside Microsoft. It's basically the ability to build a huge in-memory graph of your managed code. And code, not IL. And that turns out to be tremendously important. We're not talking about binaries. when we parse this stuff. So we are looking at the syntax tree, basically, of a compiler. You can think about it that way, logically. There are some meaningful things for us. For example, were we to, not saying we would ever do this, but were we to calculate the lines of code in this method? Here's a question. Is that 1 or 2 lines of code? Depends. Depends on who you ask. Well, is that 1 or 2 lines of code in IL once it's been compiled? Oh, and optimized, and perhaps had JIT values put in place multiple times. So many replacements have been done. Well, the lines of code that we calculate with the current code metrics tools look at IL. So when we go to architecture, analyze, and select, if I can hit that, calculate code metrics, this little used and often misunderstood lonely little feature pops up. And this feature tries to calculate things about your code like cyclomatic complexity, depth of inheritance, class coupling, and lines of code. Okay, and it does so at all of these different levels of packaging. So these are sort of package metrics, right? And then they can go all the way down to the method level, which is really cool. But it's looking at IL, which means the values that you might get here would be different were you to measure that in code. So that's a fundamental difference with CodeLens. We're able to actually parse all of the code that's in here as code, not as IL. And so that has been meaningful for the features that we've been able to develop. Also, let's have a look at this one. There's a failing test. So this indicator, the first indicator, oddly enough, is called the references indicator. So no big news there. But the second one that we're looking at here, this is the tested by indicator. What does testing mean? Now note, so far, everything we're looking at is at the method level, right? We're not looking at a class. We're not looking at a namespace. We're not looking at a project or a solution or a team project or team project collection. See how you can just keep going? World's a hierarchy, man. Nope, this is a method. And we're able to see what's covering this method by looking at those tests that are referring to it. Further, I can navigate to this method. Here's the test method that's calling me. Apparently it's failing. It has an indicator itself, this test method. Now, because we can see that this is a test method, because we can look at the code, we are able to put a different indicator in place. And this one is the test status indicator. We're thinking that there's really no good reason to separate these two concepts. Maybe we should just boil them into one. But this is how it's evolved to our current preview thinking. So here's an indicator, the test status indicator, which shows me clearly that my status is not good. And here what we see is that information that you would normally find in the bottom of the Test Explorer window. What we're trying to do here, I guess I'll say it this way. If we were hugely successful with CodeLens and these two indicators, you wouldn't need to look at Test Explorer anymore. So what about that? I could just live inside my code, writing code that tests my code, and not have to look outside my code. That'd be great. And in large part, I think we've been somewhat successful. But let's take a look at what's going on here. Well, we have an exception being thrown by an assertion framework called shouldly, and it, as you can see, chucked a wobbly. And some interval should have been 1 second, but was in fact 1 minute. So that's the bug. Well, the first thing that I might think of when I see that there's a problem with this code is rather than trying to debug it, rather than building out code maps of it, I might ask myself the following question. What's been going on with this code lately? And I'm not talking about, let's see, we're not specifically interested in the test, obviously. We are interested in this one. What's been going on with this code? There is a gentleman in Microsoft Research who was like a big-time hero of mine before I joined, and I've got to meet him. It's really pretty neat. Signed my arm. And he is a computer scientist in Microsoft Research focusing on the impact of, let's call them human realities, on your code. And I'm very interested in this because I spent some time as chief software craftsman at scrum.org where I looked at exactly that. What are the implications of iterative, incremental development practices on our architectures? How does our code evolve differently in that situation versus or compared to how it might evolve under a plan-driven model or perhaps a continuous flow model? And it turns out there are differences. This gentleman in Microsoft Research, and I'm not going to say his name because I would slaughter it. I'm so terrible at that. Published a paper several years ago proposing something that he called the organizational distance metric. The organizational distance metric kind of goes like this. You know what cyclomatic complexity is? You measure a code block and then another code block and then another code block, and that's a 3, right? Organizational distance is how far away in the organizational chart do the people who have worked on this block of code report. Weird. His paper proposes that it is the single best indicator of defects that we could possibly measure. It's a great paper. It's not a EEE paper. You can go out and get it. And we're very interested in what do human activities mean to our code. And so the first question that I might ask here is, what in the world's been going on with this code? And so we might look at, well, that. Guess that's not great. I just realized I wanted to pull up a different version of code for you guys. Let's pretend that there are 5 to 10 changes that have taken place on this method over the course of last night in my hotel room by different users of this VM. What we would learn as we dove into them is that we could see the actual, oh, this is not cool. I just need to go get a different one. Let's do that real quick. It's worth it. It's that worth it. So I'm going to go to Team Explorer. I'm just going to bail out of this guy. We will be back up mucho quick. And I can say that because I'm from Texas, not from Spain. All right. Let's see here. We want that guy, that guy. Nope, nope, nope. That guy. Cool. Okay, and we'll go back to our start timer. And see that we have 5 changes. I knew it would be quick. That was great. It's like a minute. Or less, I hope. Okay, so here's some changes that have occurred over the lifetime of this method. Version control thinks in terms of files. Even Git thinks in terms of files. This doesn't. This thinks in terms of code. The way we're doing that is that we are parsing every line of code in the version control repository on the server and building an index not unlike that which you might find on a Windows machine, the search catalog. And our teams have so far provided only into that index that which we need to provide this data, which is essentially what changes have occurred on this code element, which in this case is a method, could be a property, could be a class, could be an operator, could be an indexer. What changes have occurred there? And who's been involved? Well, it turns out in this case, Brian, Harry, plus one other person, and it turns out Julia. Now, wait a second. If we read the comments from the bottom up, because that's the order, turns out these two people probably should have gotten a room to talk. But this happens all the time because they work on different sides of the company. Really interesting. Okay, so let's look at this one. This one smells because it has quotes in it, like air quotes. So it seems that she was being sarcastic almost with her. So that must mean something. Let's open up this particular change set. So what we're doing is we open right to the change set view. We can see the details of the change set plus the change that was made. Oh, right. Look at that. Two very different invocations of that new time span, that time span constructor. So let's see. This is the one that was on the server, right? Yeah. No, that's, yes, okay, good. I got it straight in my head. Hopefully you listening to me do that helped you. So I can scroll and see all the changes in this thing, or knowing that we have this problem, I can come in here and make a fix. Okay, now hopefully, if things go well, we would have, say, 5 of 5 unit test passing. Remember that I clicked my Build on Run button on Test Explorer, I think. Oh no, that was in the other project. Oh, it did. Good, it's going. These test runs are taking a long time on this VM, and it's not because they really take a long time. That's absolutely true, and I know it sounds like I'm just saying that, but running these things on a live box, I have not had these kind of performance issues that I've had on the VM here in these sessions. All right, so here we go. We now have 5 of 5 passing. Note that the color went away. This is intentional. It's very much our decision, a deliberate decision, to not put color into your editor when at all possible. There were a few design tenets for CodeLens. Number 1, don't be annoying. Number 2, you can turn it off. And we can do that. Actually, here's a little understood feature, or a little known. See that little text box in the upper right-hand corner? Nobody knows that's there. We actually have data that proves that you don't know it's there. Nobody ever uses this thing. Watch this. I get to it by typing Control-Q, so I'll type Control-Q. And now what I'm going to look for here is someplace inside Visual Studio there must be a command that lets me configure that indicator showing up. Code, look at that, code information indicators. How about that? So this is a quick stop to any command inside Visual Studio. Pretty slick. So I'll double click this and go right to the settings, which live under text editor, all languages, and code information indicators. This will change. The strings in here will change. That's kind of what shipping means for us, apparently, is that we get to change all the strings in our resx files because marketing agreed on a name. Great. So it's CodeLens now. But we could come in here and we could turn them all off. We could toggle on just 1 or 2. We could toggle on or off just the ones we care about, etc. But of course, you would never want to do that, and neither do I. Okay. We have 15 minutes and material for that amount of time that does not necessarily focus on these indicators. So we've got other things that we could look at. However, it's been clear to us that there is a great deal of excitement and concern about this feature. And I'd love to hear from you guys right here and now about your hopes and concerns for something like this. First of all, I'll ask it this way. Do you like this? Who likes this? Raise your hand. Good. Good. The number one thing that we get asked about is performance. What's the performance impact of this thing? Should I just turn it off now? My God, that editor's already crazy slow. Here was our requirement. I don't know if you guys remember when 2010 shipped. When 2010 version of Visual Studio shipped, it got the WPF editor in it. Oh my God, it was so slow. And so Microsoft instituted a new thing for regressions against the performance of the editor. In other words, it won't slow down. They set a bar, met that bar, and we're still meeting that bar. Our requirement in building this feature and getting it packaged in and turned on was that it had zero effect on performance scenarios that are tested. Things like the time it takes to start up Visual Studio, the time it takes to launch a large application and hit F5, get into the debugger, those sorts of things. Literally, we were provided zero overhead to do that. And so your performance will be the same with CodeLens as without on the client. What about the server? I already mentioned, we can see we're getting some of this data from the server. So where do we get all that? So start timer, let's go back to start timer. So what we're doing is there is a job that, a couple of things go on with this job on the server, Team Foundation server. Pays attention to code that you are checking in now. So as code changes come in, we parse them. We parse that code that's in each change set. The code, this does not depend on build in any way. There's no dependency on team build. So as that code comes in, gets checked in, we parse it, and we write that catalog out, parsing down to currently, as I said earlier, the method property class level. We have a job that keeps up, like I just described, with incoming check-ins. We have another one that when you install your upgrade to Team Foundation Server 2013, if you happen to be an on-prem customer, we will begin indexing from that moment backwards to the beginning of life of that Team Foundation server, which, if you are a pragmatic person in any way, should scare you to death. And so it's, if we get that wrong, that is on me. Me. So we have spent a lot of time being very careful about performance on the server. I will tell you that we have a Team Foundation server. Inside DevDiv, it has a lot of data in it, a lot of code in it. We have been the first indexing runs that we did, we installed CodeLens and indexed backward to the beginning of time, took 20 some odd days. We've gotten that down to significantly a shorter period of time, still days. It is gigs of data. It's crazy how much source code is in that thing. And we are walking every code element of every branch. We are a very low affinity job. It's reasonable to think about it that way. We're not going to get in the way of check-in. We're not going to get in the way of build. If, however, you are an enterprise Team Foundation server administrator and you have concerns, one of the things that we built in the beginning was the ability to turn it off. Now, it's important to realize that of the 4 indicators that you see above that method line, plus the one that's on the test method, the test status indicator, of those 5, only 2 reach out to the server. And so there are perf considerations both in the indexing, which we're very comfortable with, and with the calls that are being made to TFS over REST endpoints to retrieve that data. So that data gets retrieved in a couple of different ways. When you open up a code file, we're going to take the address of that code file, we send a REST request, give us all the data you got about this particular file, we get that, comes back as JSON, we light up this little panel in Visual Studio. The line, just that line there across the bottom, the indicator line. The items in gray. That's one request, and that request fills in all of the indicators for the entire file. So it's one request per file, and we'll have a caching story there and all that goodness. Next, there is this action. I click one of these indicators, it makes yet another request, goes out and says, give me more detail about this class. We also have some caching going on there, so we're trying to be somewhat intelligent about that. I'm spending some time on this because I want you to know a couple of things. Number one, it is not acceptable to me that Visual Studio become Las Vegas on your desktop with regard to design and color and all that stuff. It's just, that's not what we're about. Don't be annoying. Number two, information is ambiently available. That is, like a head-up display, you can look through it when you don't care about it. You can focus on it when you do. Our intent is to enable you to look through that data right now so that you don't have to see it if you don't want to. And that means no icons unless there's something really, really important that we're going to bark at you about, like a failing test. Don't be annoying extends to the perf on the server and all those good things. Say it louder, sir, please. Is this going to be an ultimate-only feature? I don't know that that's been decided. I don't know. I'm sorry, the stack trace, the code map? Code map's an ultimate. And premium? Come on, you're an ALM MVP. Sorry, sir. I'll tell you what, I'm more than happy to pick that up with you after. Almost positive it's an ultimate feature. We kind of look at those two things as being the same. From a product team standpoint, we don't know or care who's going to get this. I mean, we care because what we actually want is to give it to everybody. We wish we could put it in Express. But before we ship, well, it's true. Because then more people would use our software, and who doesn't like that? We're the product teams, though, and we don't sell this stuff. We just eat there. So they package it differently and sell it to you in different ways, and I don't know what that is. Sorry. Extensibility has also been a very often cited question. You know, what about extensibility? I will tell you that in the first version, there will be no extensibility. And the reason for that is because we're not even sure we're doing it as well as we'd like to for ourselves, much less opening something up to you that would then cause you to hate us. So we want to ensure that we have a very good extensibility story for you. It's not to say that we're not going to have one. We definitely want one. It's very important to the future of this feature and this set of features. And I can tell you that even today, we've got some hooks in there that allow us to do interesting things like write an indicator and deploy it as a v6, right? But the APIs that allow us to do that are simply not going to be open for the first release. We will care about it, I promise. Anybody have any other thing that, yes, sir, please. Will it work for all languages? Well, short answer is no. Here's why. I told you that we're parsing that syntax tree of code, right? We're looking at the code, we're not looking at IL. And that means that we have to have a code parser. Well, there was this project on the other side of the building called Roslyn that happened to be a code parser for managed code, specifically VB and C#. We could go talk to those guys and they made their services available to us. That's how we were able to get this feature in. We want JavaScript. We want C++ badly. Will not be there for version 1, I'm sure. I highly doubt it. Yes, sir. Is there a mic in here? I'm sorry, can you speak up? And I'll repeat the question. Great. I'll meet you. Ah.
So if I open up the test results, from a failed build, and I look into my code, will this show the test covering that line?
You're really big.
Yeah, I am. Does this help?
This is unusual for me. I'm
Yeah.
a little intimidated right now. What did you say?
Don't be.
So, I'm serious. What did you say?
So, if you go to a build in TFS, it has failed for some reason.
Yep.
And I download my test results. And I get my test results tab, and I open that, and I can see what test has failed. So I double-click on it. I go to the failed test method. But this doesn't plug into that?
If we're able to see, if we're able to see the entire project in place, if you open it up like that and open up a solution, we're able to parse that whole thing, yes. In some cases, we're able to parse just a file's worth of information. We don't need a complete and total syntax tree. It doesn't even have to compile.
Okay.
But we have to have all the information that you can imagine we need to show you that test status stuff, right?
Yeah.
And I don't know what's in that. It's a tricks file, right, that comes back over the wire, and I don't know how we wire that up when we open that view of that TRX file, which is a file that stores your test results from a previous test run. It's an interesting question.
Yeah.
You just might make the backlog with that one. That was really good. Thanks, man.
Right.
Cool. Anything else? Yes, sir.
Test impact thing.
Test impact. Say more.
The thing that when you make changes to a file, it finds out which test cases you need to run again. Mm-hmm. It could do something. You could do something with this.
We could definitely do something with this. What's really cool about this feature is that as soon as you see it, you start having really cool ideas. And that's a really good one. The request being, what if we were able to assess what code needed to be retested because of some changes that I just made to some code? That would be awesome. It's on the backlog, I can tell you that. And I know that that's kind of a lame answer when you wish it were there. But it's the reality that you live with too, because I'm sure that you say that to your customers and bosses, and it's your reality as well as mine. I have a backlog. That's on it. What's interesting is that we test impact analysis in its old sort of understood way. We're winding down here, and this will be the last thing, and we'll wrap up. Test impact analysis is interesting. It's more interesting when you couple it with something like complexity measures, so that we understand that a given body of code, maybe a code block that might be a method, it could be a class, it could be a namespace, has a higher complexity value, measurable value. What we then know about that is that code coverage for that set of code should be higher to assert the same level of coverage that you would find in simpler code. You need more tests to cover more complex code. You don't really need math to figure that out, but that math exists, and we can expose it to you here. It's on the backlog. Good one. All right. Here are, once again, the indicators that we will have in your preview when you install preview. References, test as, tested by, changes to code elements, and what, or rather who made those changes. So what changes were made and who made them. And I really look forward to hearing your feedback. You hit me on my blog, elegantcode.com. Love to hear your experiences playing with this. We're very excited for you all to get your hands on this preview code and tell us the good and the bad and the ugly, because we listen, promise. I listen, we will. And thank you very much for your time today.